We are going to discuss a topic viscosity. It is a part of fluid mechanics. In viscosity, different parameters of fluids we can discuss and properties, theorems involved which explains about the viscosity we can discuss here. Viscosity, a definition, force acting between the two layers of the fluid which opposes the relative motion between them. What exactly it is? Let us take an example. You take a bucket of water. That stir the water. Water starts to rotate. That leave it for some time. After some time, the water comes to rest. But according to Newton's first law, if force is not applied in a body, body in motion should be in motion only. But what is happening here? Just we are stirring and leaving. After some time, we are not applying the force, but after some time, water is coming to rest. Then who is stopping that? There might be some force. Otherwise, it can't stop. The which force is acting? The force in between the layers only is acting. The force which is acting in between the layer which is opposing the motion, that is the reason it is coming to the rest. The force which is stopping the fluid motion is a viscous force. Right. Let us see that expression for viscous force, how much magnitude of the force, how to calculate the force, let us see. Here first layer, second layer, third layer of the water flow assume. As a flow, let us take it is at x1 distance, it is at x2 distance. It is an example I am taking, there is a water flow, nadilo neeti pravaham. So, in that flow, we are considering first layer, second layer, third layer and so on from the bottom. The first layer at x1 distance, second layer at x2 distance, assume. And the velocity of the layer is v1 here, the velocity is v2. So, how force will be depends, let us see. The force, viscous force is directly proportional to area of the layer and force is inversely proportional to, even though directly proportional to velocity, change in velocity in between the two layers, and force is inversely proportional to distance between the two layers. The layers are far away, viscous force is less. Layers are closer, viscous is more. In such a manner, inversely proportional. So, from these three equations, what we can say, three terms, what we can say the force is straight away directly proportional to A into dV by dx. F equal to some eta into A into dV by dx, where eta is called coefficient of viscosity, where eta is the coefficient of viscosity which is depend upon nature of the fluid. For different fluids, it will be having the different value. It is a constant for each and every fluid. A is area of cross section, where dV by dx is called velocity gradient. dV by dx we can call velocity. So, let us see where we have to use this viscous force. We can term like viscous force when there is a viscous force between the two layers of the fluid, that time we have to use viscous force. For the numericals, they may give that area of cross section of the layer. So, in application point of view, Fv is equal to even eta pi r square into dV by dx. Here F equal to area of cross section, circular cross section of the liquid is given while flowing. That time it is area is pi r square we can take. Here F1 by F2 in this case, V1 by V2 into X2 by X1 also we can use for the comparison of the same fluid with different velocities and different separation of the layers. that we can use for the ratio of the forces. Okay, this is a viscous force. Equation of continuity. When a liquid is flowing through the pipe, we are supposed to discuss the other one, equation of continuity. With the help of that one, the volume rate of the fluid can be calculated. What is equation of continuity? Let us see. Equation of continuity. So, other property, the rate of water flow through the pipe can be studied, volume rate can be studied with the help of the equation of continuity. So, what exactly equation of continuity? Let us see. The statement is the amount of mass enter per unit time is into a tube is equal to the amount of water leaving from the tube. Flow is a constant otherwise. Here the amount of m1 by t1 is equal to m2 by t2. Assume that m2 by t2. Here the mass enter into the tube is equal to the mass leaving from the tube. What is the mass? Here volume into V1 d1 by t1 is equal to V2 d2 by t2, where volume of the liquid, d is the density of the liquid. Volume is area into length into d1 by t1 is equal to area into L2 into d2 by t2. But which liquid is entering? The same liquid is enters and same liquid is leaving. So that the densities d1 and d2 are equal. Same liquid densities must be constant. So d will be get cancelled. Right here A1 length by time, the liquid is covering length L1 of area of cross section is A1 in a time T1, then the length covered or displacement covered by the liquid flow in unit time is called velocity. Here also A2 it is B2, length by time is velocity. Here unit time T1 T2 is equal to, let us take 1 second per second. So A1 V1 is equal to A2 V2. What I am taking just T1 T2 we are writing, but for the unit time and T1 T2 I am considering as a 1 second. Within the 1 second how much flows here is not same, that is here velocity will be differ, but volume rate is constant. Velocity displacement by time in a unit time, how much displacement is covering in unit time is a different, but total together is volume rate is A1 V1 is a volume rate is a constant. Other place also maybe area is less, velocity may be more, area is more, velocity is less. In such a manner, that is a inverse proportionate, like A into V, finally AV is constant. Here AV also we have to remember that AV is equal to volume rate. I am writing that very V is a volume, where V is a velocity, A is the area of cross section. V by T is volume per unit time, I mean to say, right? It is a constant. While using the numerical, these terms we have to use. Competitive exam point of view, we have to use A1 V1 is equal to A2 V2. Here A is obviously pi R1 square into V1 pi R2 square V2. Here pi get cancelled. V1 by V2 is equal to R2 by R1 whole square. Square of the inverse ratio of the radius is equal to ratio of the velocities of the fluid at the both the ends. In such a manner, sometimes we have to use the expression for the numerical point of view. Here, before going the Bernoulli's theorem, we have to discuss. Here, as the liquid is flowing through the cross section of the pipe, few parameters we have to discuss. That is turbulent flow and steady flow and streamlined flow. What is exactly this terminology we should come to know? That is first thing is streamline. What is a streamline? Let us see. Streamline is the path followed by the fluid particle. Path followed by the fluid particle. So that means what? Example I will give. What exactly streamline? That is, assume that after a rain, we can find the water flow on the roadsides. Okay. The water, how the water flow is there, the similar manner boat starts to move. Is that right? So the path how it is following, that if you group a locus of all the points followed by the boat will be taken as a one line, that is just like that each and every particle, if you put 5 boats, 5 different paths you will get, like it is streamlines, it will be like this, the particle is going, the first particle is going like this streamline, second particle is going like this streamline, in such a manner the number of group of streamlines they will be followed. This group of streamlines is called as a tube of flow. Each is streamline, group of streamlines is tube of flow. Okay. In this tube of flow, velocity is constant, that is called as steady flow. Velocity is different at different instant, that is turbulent flow. Constant velocity with which the entire fluid is flowing, that we can call as steady flow. And next one is turbulent, which is a different velocity, it possesses the velocity of streamline particles possess a different velocity at instant of time, a different instant of time, that is we can say that is turbulent flow. Now coming to the point, Bernoulli's theorem statement, we can say, let us take a pipe. It is very, very important concept for the competitive exams. Okay. So here let us take, it is H1 height, it is H depth. What exactly it is? We are considering a pipe through which the water is flowing, a liquid is flowing. Fine. As it is flowing through the pipe is at different heights, H1 and H2. Here the velocity with which the liquid enters is V1. The velocity with which it leaves from here is V2, area of cross section is here A1 and pressure is P1, here pressure is P2, area is A2. For the competitive exam, we should know about the what exactly the statement and what is the principles are involved in it. Statement of the Bernoulli's theorem is, for an incompressible non-viscous liquid. What is a viscous liquid? So the viscous force acting between the two layers, the flow is viscous fluid, we can say that. Example, take a what is that gum bottle and water bottle. Just pour the gum on table, water flow on the floor. Observe it. The water flow, it will be fast and gum will slowly it will move, because gum has more viscous than the water. Gum is obstructing in between the two layers, that is the motion is obstructing. In the water, obstruction is there but less obstruction. In such a manner we can say glue is a more viscous than the water. In such a manner, now we are considering a fluid which is non-viscous, incompressible statement. We are defining the Bernoulli's theorem, incompressible non-viscous fluid. For incompressible non-viscous fluid, the sum of pressure energy plus kinetic energy per unit volume is constant. That is a statement of the Bernoulli's theorem. Pressure energy, sum of pressure energy, potential energy, kinetic energy per unit volume is constant. So what exactly, how we will get this expression, how we will use for the numericals, for solving the numericals, let us see, and we will take the latter examples also, right. Let us see that. Here, let us take first one is, I will take that pressure energy. Energy is nothing but work done by the pressure. So work done is equal to force into displacement. Here force is, pressure is equal to force per unit area. So pressure is force equal to pressure into area. The work done is equal to pressure into area into displacement. Here area into displacement, what we can call? Volume. So work done is equal to pressure into volume. Fine. Pressure into volume. So here work done due to what? Work done due to pressure. So work done per unit volume is how much? PV by V is nothing but what? VV get cancelled P. So work done, the net work done here, the work done by the pressure per unit volume at H1 height, the work done at H2 height, we have to calculate, that is net work done due to the pressure is, let us take as W1, net work done due to the pressure P1 minus P2. Since P1 is P1 minus P2, here it is equation 1, let us take. Work done due to the potential energy. Potential energy here mgh, here as usual P1 is greater than P2. Sorry. Here work done is equal to, work done due to the next one is potential energy. Here higher potential energy, here lower potential energy because of height. So mgh1 is the work done per unit volume, mgh by V. Here work done is equal to, density is equal to mass by volume, volume is equal to mass by density. Here what we can write, mgh mass by density, mass get cancelled, dgh, here d we can take, d is equal to rho or d, whatever the symbol we can use. Next one is net work done due to the potential energy in between these two will be W is equal to dgh1 minus dgh2. I will take this as the net work done due to the pressure is W1, it is W2. We need to remember the work done for the pressure and work done. Next one is kinetic energy. Initial kinetic energy, here the velocity will be less, here velocity will be more. So kinetic energy, change in kinetic energy, let us take half mv square minus half mu square. Here each and every term is important while doing the numerical. So that half mv square minus half mu square. Kinetic energy per unit volume, kinetic energy per unit volume, let us take half mv square minus half mu square by V. Similarly, volume is equal to mass by density. So here what we can write, kinetic energy, the liquid flow possesses the less kinetic energy over here because the velocity is less compared to the lower edge here at H2, velocity is more. So difference in the kinetic energy is equal to, that is half mv2 square minus half mv1 square, as V2 is greater than V1. Here the kinetic energy per unit volume is K by V, half mv2 square by half mv1 square by V, where V1, V2 velocities, where V is a volume. As you know that volume is mass by density, so that we can write as half into m into m common V2 square minus V1 square by m by d, d will come up, where mm get cancelled. So finally, here we got the expressions for kinetic energy per unit volume, kinetic energy, potential energy per unit volume and pressure energy per unit volume. Fine. Let us take according to the work energy theorem. What is the work energy theorem? Work done is equal to change in kinetic energy. Work energy theorem states that work done is equal to change in kinetic energy. Here, what is the work done here? W1 work done due to the pressure plus work done due to the potential energy is equal to change in kinetic energy per unit volume. Here also per unit volume, per unit volume. Here what we got? P work done by the pressure per unit volume is P minus P1 minus P2 plus D G H1 minus dgh2 equal to v2 square minus v1 square by 2 into the divide either side with the density P1 minus P2 by D plus each and every term where I am dividing with the density term GH1 by D minus DGH2 by D V2 square minus V1 square by 2 by D. So, here D, this D get cancelled, here also D get cancelled over, then P1 by D minus P2 by D plus GH1 minus GH2 is equal to V2 square minus V1 square by 2. As you are taking P1 by D plus GH1 plus V1 square by 2 is equal to P2 by D plus GH2 plus V2 square by 2. This is a very important expression for the numericals. Let us see exactly. P1 by D plus GH1 plus V1 square by 2, P2 by D plus GH2 plus V2 square by 2. We are taking the two cross-sectional area, two expressions we got. How many cross-sectional you consider, so those many expressions will get. That doesn't mean that as total sum of pressure energy per unit volume, current potential energy per unit volume and kinetic energy per unit volume is being constant. In such a manner, we can say that as rho is nothing but density. We can write even P by rho plus GH1 plus V1 square by rho, V1 square by 2 is equal to P2 by rho plus H2 plus V2 square by 2. This we can write even the equation in term either D or rho, we can use the term for the density. Let us see that this expression how it will be useful. Now let us see the applications of Bernoulli's theorem. Applications of Bernoulli's theorem. Here what is the application? The first application, let us see. Aerodynamic lift is the application of Bernoulli's theorem. So, what is aerodynamic lift? Dynamic lift. Assume that it is a wing of the aeroplane. When air is blown across the wing of the aeroplane, these are the streamlines of air. The air is blowing across the wing. These are all the streamlines of wind flow. As the wind is flowing faster across the wing of the aeroplane, the velocity is V1 here, velocity V assume. V2 is greater than V1. Why it is so? We see. Here the surface will be streamlined. They will be here also when air is flowing across it, here much crowded of the air will take place. Here will be rushes because of the shape, streamlined shape, and velocity will be more here, velocity will be less here. Next one is pressure P1 and pressure P2. Here pressure P1 is greater than P2. As velocity is less, the pressure crowded, what is the streamlines, causes the more pressure over here and less pressure. Before takeoff aeroplane, it will be in the runway, faster, it will move until it experiences a upthrust which is equal to weight of the aeroplane. Why? Because during the motion, it experiences a upward pressure is greater than the downward pressure, resultant pressure causes the dynamic lift. What is the upward pressure? P1 minus P2 is a resultant pressure. This is also resultant pressure causes the upthrust. So, how we can use the Bernoulli's theorem? You can see P1 by rho plus GH1 plus V1 square by 2 is equal to P2 by rho plus GH2 plus V2 square by 2. Here let us consider aeroplane wing from the ground is at same height, lower end and higher end. Thickness of the compared to the height of the aeroplane wing from the ground, H1, H2 is approximately equal. So then we can make H1 is approximately equal to H2. So, we can cancel these two, fine, we can cancel. Then P1 minus P2 by rho is equal to V2 square minus V1 square by T. Here P1 minus P2 is pressure difference. P1 minus P2 is equal to rho by 2 into V2 square minus V1 square. Here P1 minus P2 is a pressure difference across the wing, right. Here pressure is equal to, you might be knowing, pressure is equal to force per unit area or thrust per unit area. So, force equal to pressure into area, as you know that. Now we can write as pressure P1 minus P2 we can write as P is equal to rho by 2 into V2 square minus V1 square. Now let us take the continuation part from here. F is equal to P into A. Fine. What is the P here? Rho by 2 into P2 square minus V1 square. So F equal to A is A as it is. In place of P we will substitute rho by 2 V2 square minus V1 square. Finally, F equal to A rho by 2 into V2 square minus V1 square. It's very, very important for the numericals, for solving the numericals, how they will ask the question. Let us see, where F is the upthrust or upward force, we can use the T also, thrust symbolized as 3T. So, rho A by 2 into V2 square minus V1 square. Whatever the symbol it is, the force which is acting, the resultant force is acting on the aeroplane wing, against the gravity is the thrust. Here how much thrust is needed for the aeroplane? The question will be framing. So weight of the aeroplane is mg. Here gravitational Fg is equal to mg. I mean to say the example of thrust, it is aeroplane wing, assume. Here upward thrust is F, downward weight is mg. These two are equal, then it will be rest. How much weight is there? That much force is supposed to be act in the against the gravity on the aeroplane wing. That will be done by, what is that, thrust, the pressure. Here, so making this equal, these two thrust and gravitational forces equal, we can write as mg is equal to here rho A by 2 into V2 square minus V1 square, fine. Where m is a weight of the aeroplane along with the passengers. Empty aeroplane means it will be always designed in such a way is more than, it is where it is depend upon area of cross section of the aeroplane wing, density of the air, V2 and V1 is the velocity of the air which is blowing across the upper and lower and upper area of the aeroplane wing. Here m is the mass of the total aeroplane wing, g is the acceleration of gravity. It is a downward, it is a upwards. These two are balancing, then it can lift. Aerodynamic lift will be takes place. It will be, that will be designed in such a way, the condition will be here rho A by 2 into V2 square minus V1 square is greater than mg. Greater than or equal is a condition for the upthrust. They may ask the question. Just simply if you learn only the aeroplane aerodynamic lift is mg is equal to rho A by 2 V2 square minus. What may be the condition for which aeroplane wing can be lift, aerodynamic lift takes place? The condition is nothing but what? As it, the expression whatever you are getting from the derivation from the Bernoulli's application, that should be much greater than or equal to the weight of the aeroplane wing. So let us see some numericals based on the aerodynamic lift. The numerical based on the Bernoulli's theorem. So let us take one example problem. In a horizontal pipeline pressure falls 10 pascals between the 2 points separated by a distance of 1 kilometer. The change in kinetic energy per oil when the oil flows from one point to another point. The density of the oil is given as 800 kg per meter cube. So Here 1 kilometer or 2 kilometers, whatever is the horizontal pipe is taken. So let us take horizontal pipe immediately. What is asking? Change in kinetic energy per unit mass. According to the Bernoulli's theorem here, H1 height difference is 0 because horizontal H1 is equal to H2 is a condition. P1 by rho plus GH1 plus V1 square by 2 is equal to P2 by rho plus GH2 plus V2 square by 2. Here as H1 is equal to H2, we can cancel these two. P1 by rho minus P2 by rho, or else we can write as we need the change in kinetic energy per unit mass, or V2 square minus V1 square by 2. V2 square minus V1, I am sending here the P1 minus P2 by rho. Here kinetic energy per unit mass or unit volume, V2 square minus V1 square by 2, this we need of, but what is it given? Pressure difference is given. What is the pressure difference is given? 10 pascals, right? 10 is the 10 pascals, the pressure difference is given. And what is the density over there? 800 kg per meter cube. It's nothing but 1 by 80. The kinetic energy can be, we can say that as difference in the energy is kinetic energy per unit joule per kg. The next question based on the aerodynamic lift and application of Bernoulli's theorem, let us see that another question, air streams horizontally cross section of an aeroplane wing of area of cross section, this is 3 meters square, weighing is 250 kg, the air speed is 60 meter per second and 45 meter per second over the top surface and bottom surface respectively. What is the lift of the, so density is 1.293 kg per meter cube. So let us see that F equal to here P1 by rho, P1 minus P2 by rho is equal to half into V2 square minus V1 square. Here F equal to rho into A by 2 into V2 square minus V1 square. Here force acting on the wing is F, rho is 1.293 into area is 3 by 2 into V2 square. Here aeroplane top layer velocity is 60, bottom is 45 meter per second and it is meter per second. It is V2, it is V1. So that is 60 square minus 45 square is F equal to, finally by calculating 1.293 into 3 by 2 into 3600 minus 2025. So the force acting on the aeroplane wing by calculating the square of the 60 and square of 45 and subtracting after final answer you will get as 3054 newtons. This much force might be act upon the aeroplane wing so that it can be lift. Another question, question number 3. The question, under the pressure head, the rate of volume of liquid through the capillary tube, if the length of the tube is double and the diameter of the bore is half, the rate of flow becomes. In this question, the length is increasing and radius of cross section is decreasing. As diameter is half, obviously radius also becomes half. In that case, how the rate of flow changes, let us see. So initial rate of flow is, let us take as Q. The final rate of flow Q dash is equal to how much? This is the question. Next we can solve in this way. The volume rate of the flow Q is equal to P pi r to the power of 4 by 8 eta L. Next Q1 by Q2 is equal to R1 by R2 whole to the power of 4 into L2 by L1. Fine. So then R1 is R, because the initial length is given here, L1 is L, R1 is equal to R. Second case, the length is increasing to L2 is 2L and R2 is R by 2. Then R1 is R, R2 is R by 2 whole square, whole to the power of 4, and L2 is 2L, L1 is L. Here Q1 is given as, we are taking as a Q, and Q2 is how much? Then RR will be get cancelled, 2 to the power of 4 into 2L, LL also will be get cancelled, 2 to the power of 4 is 2 to the 4, 4 to the 8 to the 16. 16 into 2, that is 32. So here Q by Q2 is 32. Q2 is equal to Q by 32. The radius of cross section of the tube is becoming half and length is doubled, because the rate of flow is depend upon the length as well as area radius of cross section of the pipe. Here initial length is given, the length is we are taking as L, the final length is 2L, initial length is R, final length is R by 2. In that case, second case, how the volume rate is decreases. Let us see that we know the volume rate of the liquid through a cross section of a pipe is P pi R to the power of 4 by 8 eta L. Here we will write the formula for the volume rate of the flow for different cases, like these two cases. Q1 by Q2 is equal to R1 by R2 whole to the power of 4, L2 by L1. Here R1 is R, R2 is, that is R by 2. So it is R by 2. L2 is 2L, L1 is L. By cancelling, 2 will come to the numerator, 2 to the power of 4, 2 as it is 2. And 2 to the power of 4 is 16, 16 into 2 is 32. So Q by Q2 is 32, Q2 is equal to Q by 32. The volume rate is decreases to 1 by 32 times of initial volume rate or rate of flow. So the option, correct option is third. Okay, here one more question, let us see, question number 4. If a liquid enter a cross section of radius 5 centimeters with a velocity 10 meter per second, with what velocity does the liquid leaves another cross section of the tube of radius 4 centimeters? The tube is horizontal. Here the question is given, horizontal pipe, at one edge the radius is given, that as 5 centimeters, the other end the radius is given as 4 centimeters. Then the water is flowing through the cross section of the pipe. What may be the velocity at the second end? The first end velocity is given 10 meter per second. So how to solve this question? Let us see. Here horizontal, pipe is horizontal, it is a given content. As the liquid is passing through the pipe, here area is A1, here area is A2. The liquid is passing through the tube of different area of cross section, we can apply equation of continuity. What is equation of continuity? Let us see. The amount of liquid entering into the tube is equal to the amount of liquid leaving from the tube. That doesn't mean M1 by T1 is equal to M2 by T2. You might be knowing. Here mass is volume into density by T1 equal to volume V2 into density D2 by T2. Here density, same liquid is entering, V1 is volume, volume is area into length, area of cross section into length is volume. Here area is pi r square into L. Next, keeping the area is constant, volume is constant, volume is constant, the rate of volume is constant. Here which is changing? The radius of cross section is changing. V1 plus we can write pi R1 square L1 by T1 pi R2 square L2 by T2. Let us pi will be get cancelled. R1 square L1 by T1 into R2 square into L2 by T2. Of course, T1 is equal to T2 for same 1 second. Here R1 square into L1 by T1 is V1. Similarly, R2 square into L2 by T2 is V2. I am taking T1 is equal to T is equal to 1 second for 1 second. So, velocity is R1 square into V1 is equal to R2 square into V2. Here what is changing? The radius of cross section is changing, the velocity also changing. But we need of the velocity V2 is how much here? The velocity with which the liquid is entered into the tube is V1, that is given, that is 10 meter per second. V2 is equal to how much? That is a question. Now R1, the formula is here, we need to use R1 square V1 is equal to R2 square V2. Here R1 is 5 centimeter whole square, 5 square. Here V1 velocity is 10 meter per second equal to R2 is 4 centimeters, 4 square into V2 is how much? We need to find out the V2. Here centimeter, here also centimeters, no need to, because it is a ratio. Either side no need to change the units, because it is a left side is a centimeter 5 centimeters, right side 4 centimeters. 4 centimeters means 10 to the power of minus 4, it becomes 1 centimeter is equal to 10 to the power of minus 2 meter. Here whole square is there, 10 to the power of minus 4. Here also it will become 10 to the power of minus 4, will be get cancelled. So either side if it is equal in an equation, only two terms are equated, that time no need to write the units. Here 5 square means 25, is 10 is 10, here 4 square is 16 into here V2. We need the V2 value, V2 is 250 by 16. 250 by 16 by calculating, you will get the exactly value is 15.625 meter per second. The option for this question is 15.625 meter per second, second option is correct option. Next one more question, let us discuss. It is the work done to lift a body, in water. How to do this problem? Let us see, based on that concept, the problem is here. Here work done in raising a mass of 4 kg and specific gravity is 2, immersed in a water from a depth of 3 meters to 1 meter below the surface is how much? In the question, the work done to lift the body on the ground to lift to the height h, W is equal to mgh. Work done is mgh we can say. But in the case of the water or in case of the any liquid, the work done will be different. ఎందుకోసం మనం కామన్ ఎక్స్పీరియన్స్ వాటర్లో వస్తువుని లేపడం ఈజీ, ఎందుకంటే అక్కడ బయాన్సీ ఫోర్స్ యాక్ట్ అవుతుంది. ఎయిర్లో అయితే బయాన్సీ ఫోర్స్ ఉండదు, గ్రావిటీకి ఎగనెస్ట్గా మనం పని చేయాల్సి ఉంటుంది. గ్రావిటీ బాడీని కిందికి లాగుతుంటే దానికి వ్యతిరేక దిశలో, దానికి అపోజిట్లో మనం పని చేయాల్సి ఉంటుంది. ఇక్కడ ది వర్క్ డన్ టు లిఫ్ట్ ద బాడీ ఇన్ వాటర్. హౌ టు డూ ఇట్? లెట్ us see. It is a water. In the water there is an object. Let us take this is an object whose weight is mg is acting down and buoyancy force will be act up. The total depth of the water is from here to here is 3 meters, but we need to lift it up to 2 meters because in the question it is given like 3 meters to 1 meter below the surface. Total is 3 meters. We are lifting up to here means if the object is coming to this position, it will be 1 meter below. Total here to here is 3 meters. Here to here is 2 meters. The leftover distance is 1 meter. In the question, up to 1 meter below to bring the body, how much work has to be done? That is the question. It is very important for the competitive exam. How to do this thing? The work done is equal to, we know that, force into displacement. Force is net force. We need to take net force into displacement is h. Net force is mg is weight is acting downward direction, and buoyancy force is m dash g is acting upwards. The net force is downward weight minus upward buoyancy force gives the net force. Here height is h. Now m g we can write as mass equal density is equal to mass by volume. Mass equal to volume into density. Here the two densities are there. Density of the body let us take as D, solid. Density of the liquid will take as D liquid, DL. Mass of the solid is equal to volume of the solid V, and density of the solid is ds, we will write. Similarly, mass of the expelled liquid is ml equal to V is same volume of the liquid will be get expelled. When the body is get immersed, how much volume of the body is there, that much liquid will be get expelled. So that is the reason volume is same and density of the liquid is dl. Now let us substitute the respective values in this case. In place of mass it is m solid, it is m liquid, just we can write like for our convenient. Here V into ds minus V into dl into g into h. I am taking the g common as well as h. H is anyway outside. Now V into ds into g 1 minus dl by ds. Here just I am taking the common. Which one is I am taking common? Volume and density of the solid I am taking common. As you are taking the density of the solid common, it will becomes dl by ds, right? So now V dsg will become what? Mg only, because mg only I am writing as V ds into g. Ms is V ds. V ds into g is nothing but ms into g. Ms into g is nothing but mg, normal weight of the body, into 1 minus 1 by ds by dl. I can write ds by dl into h. Here in the question it is given specific gravity is 2. Specific gravity is 2. What is the specific gravity? Here the question is density of the solid, density of the liquid is not given. Only a given thing is specific gravity is given. What is the specific gravity? Specific gravity is the density of the solid to the density of the liquid is called specific gravity. Here in the case of density of the solid to the density of water, liquid is here, dl is equal to dw, density of the water. In the question it is given like water. It is a generalized formula for all the problems. For this given problem, the liquid is given, L is given, water. So density of the solid by density of the water we can replace here. So that is mg into 1 minus 1 by specific gravity. 1 by specific gravity. So now the work done is equal to finally mg into 1 minus 1 by specific gravity into h. Here mg mass is given 4 kg and gravity g is 9.8 into 1 minus specific gravity is given, the value is 2. So 1 by 1 by 2 into height. Height is total depth is 3. We are bringing to 2 meters. Because 1 meter below we are supposed to be subject must be placed according to the problem. So the height, net height is only 2 meters. Then total is 4 into 9.8 into, it is 1 minus 1 by 2 is 1 by 2 only into 2. Then 2 will be get cancelled. So 4 into 9.8, that is 39.2. 39.2 joules. Therefore, the option is, third option is correct. Right, one more question let us discuss based on the Bernoulli's theorem. In the given question, there is a horizontal pipe in which the velocity at one end is V and the velocity is leaving at the other end is 2V. Then what might be the pressure difference across the two ends of the horizontal pipe? Here, let us take a horizontal pipe. The velocity with which here V1 is V, here V2 is 2V. Here pressure P1 assume, pressure P2. The same liquid is passing through it, it is the density is D. Density D. Next, the question is here, we need to find the pressure difference, delta P. What is the delta P? P1 minus P2. Obviously, P1 should be greater than P2, then only the liquid will be flows through the pipe. Now let us see how to solve. According to the Bernoulli's theorem, P1 by rho plus GH1 plus V1 square by 2 is equal to P2 by rho plus GH2 plus V2 square by 2. That is P1 by rho plus GH1 plus V1 square by 2 is equal to P2 by rho plus GH2 plus V2 square by 2. Here, but it is a horizontal pipe. In the horizontal pipe, both heights are same. If the pipe is taken different heights from the ground, that time we can use H1, H2 as the different heights. Here horizontal pipe, H1 is equal to H2. Doesn't mean that these two values will be cancelled because H1 is equal to H2. Now rest of the equation is P1 by rho minus P2 by rho is equal to V2 square by 2 minus V1 square by 2. We need to find out P1 minus P2 is equal to rho by 2 into V2 square minus V1 square. We need to find out the P1 minus P2 value. So that is left side. This rho is D. In the equation, in the question it is given like density is D. So in place of rho, we can substitute D. P1 minus P2 is equal to D by 2 into V2 square minus V1 square. Here V2 is 2V. Let us substitute the values. V2 velocity is 2V. So P1 minus P2 is equal to D by 2 as it is D by 2. Here V2 is 2V whole square minus V1 is V square. Now let us write P1 minus P2 equal to D by 2 into 4V square minus V square. That is obviously it will be D by 2. 4V square minus V square is 3V square. So therefore 3V square. The final 3 by 2 of D V square. The final answer, the pressure difference across the two ends of the pipe we got as 3 by 2 dV square. The option out of the four options, the first option is 3 by 2 dV square. The correct answer is option 1.